Hey everyone, welcome. If you've ever found yourself staring at AWS, you've probably asked yourself, what is the real difference between a security group and a network ACL? They both seem like firewalls, right? Well, you've come to the right place. We're going to break it all down and make it super clear once and for all. So, the best way to really get this is to stop thinking about abstract rules and start thinking about a medieval fortress. Seriously, imagine your entire cloud network, your VPC, is a fortified city. It's not protected by just one wall, is it? No way! It has multiple layers of defense, each with a very specific job.
And this is where that fortress analogy really clicks. The network ACL, or NACL for short, is the main gate, the big one. It controls what's allowed into the entire neighborhood, or in AWS terms, your subnet. The security group, on the other hand, is the specific lock on an individual room door. It protects just one thing, like your server or your instance. One is the big, beefy outer wall. The other is the specific lock inside.
All right, first up, let's talk about that outer wall, the main gate. This is your first line of defense. Before any traffic from the internet can even dream of getting close to your valuable instances, it has to get past the guards at this gate, the network ACL. So what is a NACL, really? It's a firewall that stands guard over an entire subnet. And here's the absolute most important thing to remember about them. The rules are processed in order. It starts with the lowest number and works its way up. The very first rule that matches the traffic wins. That's it, game over. The NACL stops looking right there. This rule order is everything. So let's play this out with a real-world scenario, something you might actually try. Let's say we've got a basic NACL that just allows all traffic by default. What do you think happens if we add a new rule, let's say rule number 101, that specifically says deny my personal IP address? Okay, so check this out. Our first rule, number 100, is a wide open allow all. Then, right after it, at rule 101, we put our specific deny rule. Seems logical, doesn't it? We've explicitly told it to block my IP. You'd think that would work.
But nope, I still get in. My connection sails right through. So what happened here? Why did it fail? It all comes back to that rule order. The NACL started at the top. It saw rule 100, which allows all traffic. My IP matched that rule, so the NACL said, great, you're allowed in, and it immediately stopped processing. It never even got to my deny rule at 101.
Okay, round two, let's fix this. And the fix is surprisingly simple. All we gotta do is change the rule number. This time, we're gonna put our deny rule at number 99, so it comes before the general allow all rule at 100.
And boom, access denied. It works perfectly. The NACL checks rule 99, it sees a match for my IP, it executes the deny, and it stops. This is the lesson for NACLs, folks. The lowest rule number that gets a match wins, every single time.
Okay, so we've made it past the main gate. Now we're walking up to a specific room, and there's another guard at the door. This is our security group, and this is where things get really different, because security groups are stateful.
So what in the world does stateful mean? It sounds complicated, but it's actually super powerful and makes your life way easier. A stateful firewall remembers the conversation. If you create a rule to let a request come in, the security group just remembers. It automatically knows that a response needs to go back out to complete the conversation, so it lets it through without you having to write a whole separate rule for it.
All right, another lab scenario for you. Picture this. I set up a security group, and its only rule is to allow web traffic from my specific IP address. It's working great, but then I switch on my VPN. Suddenly, I have a brand new IP address that the security group has never seen before. What happens when I try to hit my web server now? So what do I see on my screen? Just nothing. The browser tab just spins, and then, bam, timeout. And this is perfect. This is exactly what we wanted to happen. The security group, our personal bodyguard at the instance door, saw a request from an IP that wasn't on the list and slammed the door shut. Job done. And this really gets to the heart of what being stateful means. In one of the examples that inspired this, a command was run from inside the server to fetch something from the internet. The response came back without a problem. And as the source material says, we didn't have an outbound rule. The response traffic is coming back purely because this is a stateful firewall. Think about that. The firewall was smart enough to know that since a request went out, it should expect a reply to come back in. Okay, we've looked at the main gate, the NACL, and the room door, the security group. Now let's put it all together.
Let's follow one little packet of data on its full journey, from the wild internet all the way to our server, to see how these two work in harmony.
All right, here comes the request, flying in from the internet. First stop, the subnet. The NACL takes a look, checks its rule list. Yep, you're good. Pass. The request moves on. Next stop, the instance itself. The security group checks its list. You're on my list. Come on in. Pass. We're in. The server can now process the request.
Now for the trip back home. Our application has the data, and it's sending the response. Because the security group is stateful, this part is easy. It remembers that initial inbound request, so it just waves the response packet right on through. No need to even check the outbound rules for this specific conversation. It's a free pass out the door.
But hold on a second, we're not out of the woods yet. The response still has to pass the main gate, the NACL, on its way out, and remember what we said? The NACL is stateless. It has the memory of a goldfish. It has absolutely no idea that we just let this traffic in. So, how in the world does the response get out?
And the answer, the magic key, is something called ephemeral ports. Basically, when your computer sends a request, it also picks a random, high-numbered port and says, "Hey server, when you're done, send the answer back to this temporary address." So your stateless NACL needs an outbound rule that says it's okay to send traffic back out to this big range of temporary ports. If you forget that rule, the response gets blocked at the main gate, and your users get nothing.
All right, we've been through a lot. Let's put everything on one table, a head-to-head comparison, to really nail down the differences and help you decide which one to use and when.
This right here, this is your ultimate cheat sheet. Print it out, stick it on your monitor. Security groups are at the instance level. NACLs are at the subnet level. Security groups are stateful. NACLs are stateless. That's a huge one. Security groups can only have allow rules, while NACLs can have both allow and deny rules. And look at the defaults. A security group locks everything down by default, while a new NACL lets everything through. Very different philosophies.
So if you're going to remember just a few things from all this, let it be these. Security group, think room door. It's stateful, it protects a single instance, and it only allows traffic. Network ACL, think main gate. It's stateless, protects a whole subnet, and can both allow and deny. You use the NAC for big sweeping rules, like block this one bad IP from the entire neighborhood. You use the SG for the detailed, fine-grained stuff, like only let this web server talk to that database.
And that leaves us with one final question for you. Now that you're an expert on the rules of the road, if you spot a single malicious IP trying to attack your network, which tool are you reaching for first? Which layer do you use to shut it down completely before it can get anywhere near your resources? The answer, as you now know, is all about using the right tool for the right job.